Hello, welcome to my bench. This is your first time here. Hi, my name's Dave. I repair electronics, mostly for radio stations and some ham equipment and some other things. But if you're returning, welcome back. Today we're going to test some meters. I want to figure out. Well, like the title of this thing says, who can I trust? We know most of the meters are going to be all right. I mean, as far as just regular measurements and stuff like that. But I want to find out what's the big difference when you're measuring in circuit, and who can I trust on a meter here? So we've got a bunch of them. We're going to use my Fluke scope meter here, my 97 scope meter, as the base. We're gonna say that that's right. I've measured it against everything I can find, and it seems to be pretty darned accurate. So we're going to use this is the accurate meter, and the rest of them we're going to go measure against. So what have I got besides the Fluke? I've got this little guy, which is I did a video on this a while ago. It's a MT8206 Must tool. It's the one with the little graphing thing on it. For voltages and frequencies and stuff like that. We're not going to use that part today. We're just going to use it as a regular meter. This is a cheapie, 20 some bucks. I've got this guy over here, which is a Unity a little handheld meter, true RMS, 2,000 count. This one I believe is 6,000. I think this one's 2,000 count. Its big claim to fame is it's got current without breaking the line. You just put this around even a DC, and it'll tell you what the current is. But we're not going to use that either today. We're just going to use it as a regular meter. I've also got this little DT71. It's a little, tweezer meter. We're going to check that. It'll do resistance and capacitance and diodes and other stuff. It'll even do some frequencies. But, actually it puts out a frequency. It doesn't read it. We're going to test... We're going to test that, and we're also going to test this little talking pen meter here. I got this specifically because I have a blind friend that uses. He does some electronic stuff, and he does some radio. He has a little radio station thingy, but he to measure batteries and voltages and things that he can do. He's very capable and does it quite well. But I thought a little talking meter would be nice for him, and I want to find out if it's any good at all. And I also have, up here in the left-hand corner, you'll see my Vici, 8145, my basic bench meter that I use is up in the top left corner in the white. And the one below that is my peak meter, that digital multimeter MS 8236 that I use on most of the videos because it has USB output directly to the computer. The Vici has a serial RS-232 output, which I finally managed to get to work through a serial to USB cable, and that was no mean feat, let me tell you. Anyhow, so there's our meters. So now, first of all, we got to take a base test here. So I'm going to take, this is a 27 ohm resistor, and you'll figure out why I picked this one in a little bit. But we're going to take the Fluke meter and test it, find out what the resistance is for this for this 27 ohm resistor. We're going to count that as the baseline. One of the reasons why I chose 27 ohms is because my fingers, if you look at my fingers, I can get like 25 megs out of them, are not going to affect 27 ohms in any way. If I chose something higher, couple of megs or a couple of 100K or something like that, then my finger resistance would be a burden on the resistance, but at 27 ohms it won't. Plus I got another reason, which I'll show you here in a minute. So we're going to measure this, and we're going to get the wires out of the way. So there we got, looks like 27.1. Well, it's a 1% resistor, so it should be. 27.0, 27.1. So we're going to call that the base for this. And now we're going to measure it with this little must tool over here. And this thing's not quick, but it says 27.1, 27.2. So that's pretty close. We'll go with that. So it's on. Then we're going to measure it with the Unity and see what it said. Well, bring this over here so you can see it. Hopefully I can get it to tilted to a point where you can see it. It says 27.0. So we'll call that good. So far, they're all pretty close to each other. Now we'll measure it with this guy. If I can get it to turn on. Really? There we go. All right. It is in resistance. We'll put it across there. This one says 26.9. That's pretty good. So 27 ohms for that also. And now we'll measure it with this little meter as a baseline. And you hear that beep? I don't know if you can hear that or not. This thing thinks it's a short below 50 ohms. And unfortunately, I don't know how to turn that off. It says something in the manual about it. Hitting fast beep or fast resistance or fast continuity. But I can't figure out how to turn it off. So it won't talk to you and tell you what the resistance is below 50. It'll just beep at you. But it says 27.3. So it's about 0.3 high. Not terrible. Alright, so let's do the Vici meter. That would be the one on the top that's white with black. And it says 27.74, somewhere around there. That's a little high. Of course, I got these leads. One of my leads reading 0.5. Yeah, the leads are reading 0.5, but didn't test those other ones. But the whole point is it's still, oh there, 27.3, better contact. 27.2, 27.3, that's good. And finally, we'll take the bottom one there on the screen, the black and yellow, and we'll read it. And it is reading. It is not reading. Why you no read? Okay, so I ran out of USB sources. I've got too many things running at the same time here. But I managed to get them all back up, I think. We'll give it a shot here. We were on this little meter bag. I got a ton of red and black leads. I gotta trace them all out periodically. Okay, here we go. So now on the black and yellow one, we'll take a measurement of this resistor, 27 ohms. and it says 27 ohms. All right, so everybody pretty much agrees. So now what I want to do, take these guys and set them all aside, and I want to measure inside of this, it's a Shure, what is it, the M267 professional mic mixer. I think I showed this before once or twice or something. Anyway, it's just a old Shure with standard basic components, no surface mount, just basic stuff. So let's take a couple of resistance measurements with, you know, with our base here to start with. So R242, here's a good one. We'll get this one, and it is, come on, it is 3.31K. 3.3K, 3.31 with our fluke. Let's turn this so it's back on again. And we'll measure it with this meter now and see what it says in circuit. I haven't done this, so I don't really know. This says 3.289. So it's got a little bit of a burden in there, but not very much. That's not bad. 3.29, somewhere around there. Now we'll try the little Unity and see what it says. Put it up here so that you can maybe see it. Same resistor. We'll go the same direction. And it says 3.29K versus 3.31. So that's pretty good. All right, now we'll try this guy. And for this, I'm going to have to bring you down in a little bit here, if I can, so that you can see it. And let's see, negatives over here, because we want to be on the same side in case there's something in there that it's measuring. And it says, can you see that? Maybe if I got on it, 3.28K. Okay, that's close. We'll do the little talking meter.
Already on auto mode.
And negative over here, positive over here. 3.30, so that's accurate also. Let's take the Vici. Measure it here. And it says 3.2853. That's pretty close. Not exactly, but it's pretty close. And finally, we'll take the peak meter and we'll measure it 3.290. So they all agree very closely on resistance for that particular resistor. So let's pick another one here. Let's take this one, R329, plus here, minus here. And see what it says. It says 26.9K. Pretty stable. It's good for that one. That's our base, 26.9. So let's take this little meter over here, this little must tool, see what it says. 26.85, 89, 26.991. Okay, so there's a capacitor in there somewhere, a little one. All right, let's take this one. Measure him here. $26.8, that's good. Let's take this guy. Negative side there. On resistance. That's one thing I do not like about this is every once in a while you'll tap the back of it with your finger. Well, there's several things I don't like about this. The big one is it does not have reverse. You have to have it the right direction. All right, so what does it say? Hard to get on there. Well, I'll tell you, it says, dang it. All right, without hitting the thing, I'll just tell you what it says. This one says, come on, get on there. All right, so this one's measuring 260. Let's see if I can get you down here so you can see this. Touch you without hitting the back of it. Because if I hit the back of it, it'll change what it's doing. Come on. See that bouncing around there? This thing isn't measuring for hoot. It's saying something like 290, 300K. And just going all over the place. If I reverse it...
It's about to enter steady state.
Yeah, that means it's shutting down. If I reverse it, it's doing the same thing. So that one is not reading correctly. Let's get the Vici and measure it here. That would be the white one on the top left. 26.6 and climbing a little bit. Went out of focus. Why'd you go out of focus? Come on, focus. Thank you. Yeah, so it's right here. And it's reading 26.8, 26, and climbing a little bit. So that's approximately correct. And now for the peak, which is the yellow one, 26.8. All right, so we had one failure already. That would be this guy. Interesting. So let's move off of resistors. So all of these except this one did all of both the resistors we looked at did pretty well. Let's go to Diode Test. Select. Here's Diode Test. Meter, Diode Test. And there's Diode Test on that. I can't do diode. I mean, I can do it, but you won't see it. I'll have to tell you what it says on the Vici. This one, select. There's Diode Test on that. We'll get to that when we get to it, and we'll get to this when we get to it. All right, so let's take the scope, the fluke, And find us a diode. How about right here? Here's a diode. So negative on the cathode and that on the anode. So it says about 0.231 in that direction. That's with a negative probe on the cathode. And 274 on the reverse. Okay? So 0.231. Okay, and 1.274. Okay, so this guy's on diode. Let's check him real quick. Negative there. So it says about 0.233. That is correct. And in reverse, 0.795. So it's nowhere close. This one, the Fluke 97 said 1 point something. This says 0.795. So it's not right. Let's try this guy. See what he says. Got to be able to get to it, and you still see it. Okay, so this says 0.317. 0.318 in reverse or forward. So that's off. And in reverse, 1.6. 1.625. So it doesn't agree either direction. Okay. Let's try this guy in diode mode. I'm just going to read it to you because it's too hard to see. I'll just tell you what it says. In one direction, it's not reading anything. And in the other direction, it's reading 2.15 volts. And this is part of the meter circuit, this diode here. And it's making the meter just go slap, 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 slap. But it's reading 2.2 volts one way. And it won't read it at all the other way. Interesting. Yep. So this doesn't agree with anything at all. Let's try. I'll tell you what the Vici says because you can't read it up there. Negative. It says 0.268. I can live with that. And the other way around, it says 1.339. So it's fairly close to this, to the Fluke. And then finally, let's go with the with the peak meter and read it. And it says 0.305, so it's off from the Fluke also. And it says nothing. 0.420, so that's okay, kind of forward, but reverse, it's way off. Try that again. Yeah, it either won't read it at all, or it reads 0.4. So it's not reading it at all. I can tell it's on there because the meter's slapping over against the side. All right, well, that the peak meter doesn't agree with it. Let's take one more time with this guy, with the Fluke, and look at it just for the fun of it. Here we go. 0.233. And 1 point something in reverse. All right, so this shows you that different meters during different functions read totally differently on in-circuit testing. All right. So now let's try some voltages. I'm kind of interested to see if there's going to be any big burden voltage problems with any of these. Even though they all have extremely high input impedance, I want to find out if there's any voltage problems. So I turn this thing on, it's set up and it's running. So let's put this on volts DC. And I'm going to go on this transistor back here. I think it's these two. Well, maybe not. Maybe it's... Well? Oh. Yeah, you're on. Let's try this transistor here. Oh, I forgot. Using the wrong thing here. Not sure I like this. I wish that on this meter, I wish that the voltages went on the regular plugs coming out. It does use the same ground, but you have to use a probe, which I've got on ×1. So let's take this one and see what it says. -5.9. What I'm looking for is the so we're going to say -5.9, just as a random, out of the gate, -5.9 volts with a negative there. Let's try this one. See what it says. Okay, what mistake did I make here? This has got to be on ×10 because this thing requires it's set up to be ×10. So basically it's going to be 0.58. It makes more sense, doesn't it? Okay. Yes. So we're looking at 0.595 volts. Minus 0.595. Now that I got ×10 probe on there. That's confusing when you first start using this thing. All right, this one says -0.581. That's close enough. Let's put this one on voltage. Big complaint about this guy is it comes up automatically in AC voltage. It's not meant to be a bench meter, I guess is why. All right. And you have to hit select to get it to go. All right. So this is measuring 0.581 also. That's good. Let's take this, and I want to read voltage. Okay, voltage. Let's see. Can't do this one in reverse. This one only goes forward voltages. And again, I hit that stupid button. All right. What does it say? 0.574, I think. Sorry about the head. 0.575. So it's reading it okay. Approximately okay. It's not perfect. And let's try the talking meter. in auto mode. It's not high enough, so we got to take it
DC voltage measurement.
to DC voltage measurements.
DC minus 0.584 volt.
Okay, 0.584 volts, so it's good. Now let's try the Vici on voltage. It should be 5.5 of something. We got what? 0.58 minus 0.5819. That's good. And the finally the peak meter. And I got to put it on voltage too. Minus 0.581. So they all agree quite closely with voltage. That's good. So what else we got? Well, we got capacitance. This will be interesting. I turn this off. This won't do capacitance. We'll just kind of throw it in here and see what happens. Let's do this one for capacitance. Select auto. All right, so we'll pick one. How about this one back here? We'll try this one. Here's the negative side. Here's the positive side. Now this is in circuit. It's reading 1.14 nanofarads. Did not like that. Let's try another one here. You got to give them time. It says overload microfarads. What the heck? All right, so let's stick this over here into the millifarad area. And wait for it. Charge up the cap. Okay, so basically in circuit, this thing is worthless for capacitors. I kind of figured it would be. We'll do this just one more time on something else. Here's a 5. Here's a 5 here. Five microfarad. It just says overload. It has no idea what you're trying to do. Let's try this guy.
Voltage measurement. Capacitance measurement.
Capacitance measurement. And we'll do here and here. If it goes blank and then it comes back without flashing around, yeah, so that's not going to read that. Let's try one over here. In-circuit measurement of capacitors is just not well done. Well, this is 28.77.
28.75 micro.
Okay, 28.75 microfarads. And this is a 20... I don't know. When people put capacitors in, why don't they put them in so that you can read them? 22. So it's 22 microfarads. So it's reading it as 28. This little guy read it. Capacitance on this little proby thing. Wow, 22.9, 23, 22.1, bouncing around a little bit, but around 22, 23 microfarads. That surprised me. So let's put it over here on this 5 microfarad one and see what it says. Between 7 and 8 microfarads. Well, darn. This one says over. I'm just checking because I'm really quite surprised about that. So it actually did read it a little bit. It's saying over. And 38 microfarads. So this actually will read, let's try this. Nah. This goes to overload. This goes to, this one should read it. It read the other one, so this one is, it'll go blank. And it's saying 57, 58 microfarads. And these are 47 microfarads. So it actually is reading the thing. That's another thing about this. If the thing doesn't stop, if it doesn't stop for a while and it's fluctuating back and forth, it'll never say it to you out loud. All right, so I think, can we get capacitance on the screen on this one? Maybe. I have no high hopes for this at all. So we'll take this one, because this Vici meter is just horrible. It says, as it proves me completely wrong. 5 microfarads is showing up at 5.38. Let's take a 47. 49.7. Okay, so this thing is just taking... I hate it when it makes a fool out of me. All right. And over here, 25 on the 22. So the Vici is doing the best at this point. So let's see what this one does. Function, diode, capacitance. And let's read this guy. This will be your black and yellow one. It's kind of just flashing around. No, it ain't going to read it. Too much interference with other stuff. What does this one say? This is 47. It's reading it as 68, 69, 70. So that's nowhere near. And this is 22. It's high, 35, 34. All right. The reason this works like this and what I've been showing you in the capacitors is because all of these things measure capacitance in a completely different way. Let's turn on the scope real quick, and we'll get done with this in a minute. All right, here's my scope, and we're going to look at the different. We're going to look at the different ways that you get an output when you're measuring capacitance from these. This is going to be the little must tool, the graphing one, and if we look at it, take it off of DC, it does put some DC on there. If you look at it, we'll leave it there, and it gives it this really interesting looking. I forget what you call that waveform, but that's what it gives it, and it is approximately, let's see, about 11.9, okay, 12 kilohertz. So it's reading about 12 kilohertz across a capacitor on that shape, okay? This one, well, we didn't do this one, did we? I don't know if this will read it at all, or did we do this one? I don't know. Let's do it again. So, on the 5, it's thinking about it, and it's flashing back and forth between milli and microfarads. So it doesn't know what it's looking at. And see what it does over here. So it says 33, about 33 microfarads on 32, and 114, 106 and dropping, 98, 97, 82. You're going to have to wait a while for this to get down to 47. It's not going to make it. So it's going to read it like in the 60s or low, high 60s, low 70s. But what is this one doing then as far as same thing, different frequency? Okay? And the voltage is negative a little bit instead of positive. And the voltage changes as it's measuring capacitance. That's my thumb on it. That's interesting. So what base does it run? So its frequency is approximately, I mean, this isn't going to be real accurate here, 4.5 kilohertz. So this one's running at 4.5 kilohertz, but when I put my finger on it, it's searching down to 2 point something, about 2.53. All right, so this one's variable when it goes to read them, between 2 and 4 kilohertz. Interesting. What does this guy do?
Already on auto mode. DC volt, AC volt capacitance measurement.
Okay. So this one, it is also variable. And its frequency is approximately, I mean, it's varying, like I said. About 3.2 there, with me touching the probe. And a
0.174 nanofarad.
It's measuring the input to the scope. About 3.5 kilohertz. So that's 3.5. This one is 12, did we say? 4.7, somewhere around there. This one that actually did a pretty good job, which surprised me a lot. Let's try it. Okay, I got to get it in capacitance mode, CX. It says 164 picofarads. Okay, it's going off the screen with voltage. Of course, I'm down to 0.5. What is it doing? It's doing something, a lot of... So it's measuring it at sort of a pulsating, let's stop it, and measure it. It's approximately right. So about 700 kilohertz. But 0.7299 megahertz. Goodness. I'm kind of surprised. Is that thing still recording? Yeah. Okay. So that's why this one read, I mean, in circuit it's reading 0.7299. Alrighty, let's try the Vici. See what it says. If I can get the things, this will be the end here when we get this done. All right, so the Vici isn't, so the Vici is reading it at about, and it's fairly constant, it's not, about 16 kilohertz. So that's probably why the Vici also read them in circuit. It's higher, much higher in frequency, but 16 kilohertz. And finally, the other one, the peak meter. Let's see what it says. So they all use the same method and the same form. Boy, the peak meter puts out a lot. And when I touch this one, it changes frequency. What is it saying? It's saying about 13.5 kilohertz. So the ones with the higher frequency did a much better job reading in circuit than the than the ones with the lower frequency, but they all use pretty much the same ramp. That they're all alike. So, and just for kicks, here's a real capacitance meter. I just want to find out. I'm in capacitance mode. Too many. Wow. Okay. Let's see what this does. I mean, this thing, its job is capacitance. Much lower frequency. Much lower. But this thing doesn't do in-circuit worth a hoot. I mean, it's terrible in-circuit. So let's see what it says. About 27 hertz. So this thing's reading 27.7. Does it change when I touch it? A little bit, but not much. All right. So this meter is actually designed for reading out of circuit, and it does it at a low frequency for high value capacitors to make sure that you're reading them at a frequency that they will be used for, not in the kilohertz range. That's the difference. I mean, that's what that's made for. So anyhow, well, there we go. So what's the conclusion here? For the most part, in-circuit resistance can be fairly accurate. You can tell if it's way off.
About to enter steady state.
Okay. You can tell when it's way off easily because it's just not even anywhere close to this like 3.7K that we had here and this 27K or whatever it was down here that we had. That's the way they're marked. If they're way off, then there's something disturbing them in there. So most of the meters will read the resistance in circuit fairly well if there's nothing disturbing it. It's kind of a toss-up on diodes. it depends on the meter and how the meter, reads the diodes. But, just put a voltage across it. This little guy, if you go to measure it, it actually puts a pulsed voltage across it. And it's not in identify mode. It would regular just diode mode. It goes click, 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 click. I mean, on the meter here, it's putting a pulse voltage across it, which is not what the rest of them do. They just put a voltage across it and read it. So this one's completely different, but they all read different things, so you can't really trust it. Capacitors in circuit, that is a toss it up in the air and see which one works method. It's depending on the frequency, the amplitude of the waveform, with that triangle waveform. Depending on that, it's going to give you different readings or not read at all. So I guess the moral of the story here is, unless your device is designed specifically for measuring in circuit, like this ESR tester, it is designed specifically for measuring in circuit. Any in-circuit test you take with a meter that is not designed for it, you kind of got to take with a grain of salt. The Fluke read everything I expected it to. The way it does, it doesn't do capacitance, but it read everything exactly like it said on the board. But then it's also, what with this thing was a couple of $1,000s. Okay, this little Mus tool, it's okay. It did voltages, it did resistance, okay. Capacitance, diodes, yeah, maybe. Sometimes it did, sometimes it didn't. This guy really kind of surprised me a lot. It did a lot better than I thought, but it also fell down on diodes, but it did capacitance and resistance perfectly, and voltage. I mean, voltage is voltage. I expected all of them to do that. This thing, as far as reading capacitors in circuit, I was really, really surprised. The nice thing about this, though, is you can take this on a board and just go around real quick and see what you got, especially if you got two sides that are the same, like in an amplifier. You can go, one of these things is not like the others, really quick with this. But it fell down badly on some resistances, like this one here. I mean, it just did not work right at all. It's order of magnitude wrong. Okay, so we don't know. The Vici, that's pretty much my standard, mostly because it's bright and it's there and it shows up on the screen now, and it's not a bad meter. It has its flaws. It's a weird 8,000 count, but it does pretty well, and I was kind of surprised that it read these capacitors in circuit. So it was a good baseline meter to be able to use. And the peak, resistance and voltage was okay. Capacitance off and on okay. Diodes, not so much. It failed badly on one of the on reverse on the diode. It just wouldn't read it at all. Anyway, so the moral of the story, and this little guy, this Unity, kind of surprised me too. It did pretty well. But this isn't designed to be a bench meter. It's only 2,000 counts, for crying out loud. It's a good ammeter for DC. But there you go. What did we learn? Well, probably what we already knew. If you're going to measure stuff in circuit, you takes your chances on whether you're measuring it, it's being measured correctly or not. Just remember that. So, hey, thanks for stopping by, and don't forget, I've got a Patreon channel if you'd like to support me at patreon.com/AERVblog. I'm also up on Odyssey. Don't forget to subscribe down there in the bottom, and ring the bell if you want to know when I do more stuff. And I got a question to ask you guys, and we'll think about this. Anybody want me to do a live show, just not even so much about electronics, or maybe some, but talking about life in radio broadcasting and how I got into electronics repair and all that kind of stuff? If you did, leave comments down on the bottom, and we'll see what we can do about it. But hey, thanks for stopping by, and till next time.